where the problem comes because it's pretty hard to design a lithium-ion battery that lasts a long time.
Batteries in current Tesla models are estimated to last for around 200,000 miles or more than 20 years before charge capacity begins to drop by more than 20%. Recently, the company unveiled a design for a new electric vehicle battery that could last up to 100 years before needing to be replaced. So, how does this new battery last so long? Let's find out in today's episode of Tesla Car World. Welcome back to our channel, friends. Before we begin, please show your support by subscribing if you haven't already and ringing the bell so you won't miss out on any of our interesting videos in the future. Now, let's get started with today's content.
Hopefully I'm a good weapon. Anyhow, what are we going to do? How are we going to try to improve Tesla's projects? Like, what's this research partnership?
Tesla's Advanced Battery Research Group in Canada, in partnership with Dalhousie University, has released a new paper on a new nickel-based battery that could last 100 years and that couples the high energy density of nickel batteries with the long life cycle of lithium iron phosphate cells. Back in 2016, Tesla established its Tesla Advanced Battery Research in Canada through a partnership with Jeff Dawn's Battery Lab at Dalhousie University in Halifax, Canada. Don is considered a pioneer in lithium-ion battery cells. He has been working on lithium-ion batteries pretty much since the day they were invented. He is credited with helping to increase the life cycle of the cells, which helped their commercialization. His work now focuses mainly on a potential increase in energy density and durability, while also decreasing the cost. The group has already produced quite a few patents and papers on batteries for Tesla. So, how does the new price of the battery compare to Tesla's current 4680? The promise of nickel-based battery chemistry is explained in this work. The researchers say that they have optimized production costs so that the new battery costs less than half of Tesla's current 4680 cell. This new technology requires fewer battery cells, aids in the resolution of material shortages, and lowers the cost of an electric vehicle. As we know, each 4680 pack costs $7,400 to produce, which means we get a cost per kilowatt hour of $104. So the estimated price of the new battery will be around $50 per kilowatt hour. How much money will you save by using this new battery? Tesla battery replacement is much more difficult than replacing the battery of your iPhone or other device, especially in the newer models where replacing the battery can involve more than 140 separate steps. This is almost always done by a professional, especially if the car is still under warranty. A Model 3 battery might cost more than $13,500. The labor cost is anticipated to be in the range of $2,300. Therefore, the total cost of replacing the battery might be around $15,800. We know the Tesla battery is under warranty for 8 years or 50,000 miles, so you can save a lot of money because the new battery can last 100 years. It could even be reused in newer models and used several times over. What is the energy density of this battery? In the quest to develop the perfect battery, energy density is key. The paper describes a nickel and manganese-based battery chemistry meant to compete with LFP battery cells on longevity while retaining the properties that people like in nickel-based batteries, like a higher energy density of about 300 watt-hours per kilogram. This is significantly higher than current Tesla batteries. For comparison, the analysis returned 244 watt-hours per kilogram of energy density for an almost new Model Y 4680 battery cell, compared to 269 watt-hours per kilogram for the ubiquitous Panasonic 2170 cells that Tesla uses in its long-range vehicles here in the US. Less density means a bigger battery pack is required to go a given distance. Higher density batteries take up less space in a car and let you drive farther. Speaking of farther, how far is the range of the new battery? With some quick math, we can put the Model Y's 4680 battery's capacity at around 66 kilowatt hours, and its range rating is at 279 miles. You'll be surprised then when I talk about the range of the new battery. The researchers say that it will have a range of 500 miles. It's equivalent to the range of the Tesla Semi with 900 kilowatt hours of battery. This is quite the monumental breakthrough in the battery industry. So, will this battery actually have a lifespan of 100 years?
Whether the lifetime of the cells will be dramatically improved.
NMC cells, particularly those balanced and charged to 3.8 volts, show better coulombic efficiency, less capacity fade, and higher energy density compared to LFP cells and are projected to yield lifetimes approaching a century at 25 degrees Celsius, authors of the study wrote. Excellent lifetime at high temperatures is demonstrated with electrolytes that contain lithium bismuth salt, well beyond those provided by conventional lithium iron phosphate electrolytes. Maintaining a temperature of 25 degrees Celsius may be unrealistic in real-world conditions, but Teslas do have the best battery thermal management systems currently available on the market. It has long been known that relatively stable temperatures result in a prolonged battery life expectancy. With a 100-year capacity, a battery pack will be functioning long after the vehicle has degraded. In contrast, at 0 degrees Celsius, the performance of the 4680 batteries will decrease by 10 to 20%, and at negative 20 degrees Celsius, the performance is only about 60% of the original. It's critical to consider how the new battery will impact the environment. The new design may be able to function with little or no cobalt. This is critical since cobalt mining can result in contaminated water, air, and soil, as well as miners suffering from respiratory and other health issues. With low or no cobalt in the battery's composition, the new battery design would be capable of giving identical results and performing in the same way. While this improves sustainability and reduces questions over the ethical sourcing of cobalt, it also offers an insight into the direction of battery development that Tesla researchers are now taking. Tesla has decided to continue working with Don and his team of geniuses until 2026. Here's to a future where electric vehicles are less expensive and more efficient. We can surely see Tesla exceeding range expectations in the future. So, what do you think? Excited to see new battery chemistry that can last 100 years? And how do you think this breakthrough will change Tesla's vehicles? Let me know your thoughts in the comments section down below.
I think one of the things that troubles me most is that we don't yet have a truly affordable car, and that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down. We've got to make, and we've got to be better at manufacturing, and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough.
Elon Musk has said that batteries are key to scaling electric vehicle production and moving towards sustainable transportation. New battery cells other than the 4680 will appear and break into Tesla's Model Y, making it superior to the competition. So what amazing advantages are in store for the world of EVs?
特斯拉不管怎么说，它是一个很成功的一个企业。比亚迪是非常对，比亚迪很尊重特斯拉，我们也很佩服特斯拉。我们现在跟伊隆马斯克也是好朋友。是吗？因为我们也给他马上也给他供电池，对，我们也给他，大家也是一个朋友关系。首先他起点比较高嘛，他采取的高举高打，他在美国在这种资本市场融资也很。
As rumors from a year ago anticipated, a prior supply contract had already been signed between Tesla and BYD, or Build Your Dream. On October 21st of last year, a source close to BYD told a local Chinese media outlet that the manufacturer had received an order from Tesla for 10 gigawatt hours of LFP batteries. In early June, BYD Executive Vice President Lian Yubo announced in an interview that BYD would soon supply batteries to Tesla. On the afternoon of August 10th, a number of people familiar with the matter revealed that the Blade battery supplied by BYD has been delivered to Tesla's Gigafactory in Berlin, Germany, which is also Tesla's first superfactory to use BYD batteries. Tesla vehicles can roll off the assembly line in as little as 1 month, that is, from the end of August to the beginning of September. This is a surprising turn of events if it turns out to be true, but neither Tesla nor BYD are confirming it right now, though BYD has previously confirmed plans to supply Tesla with battery cells. Tesla's CEO Elon Musk has said that ramping up battery production is crucial if electric vehicle adoption rates continue to rise. They plan to purchase every available battery cell available. Chinese sources said that Tesla had some of the most stringent requirements on the thickness and precision of the batteries they were getting. BYD really had to work hard and improve its processes with the next generation Blade battery to meet the Tesla standard. Then, some information revealed that the second factory using this battery line is Giga Texas. Tesla's Model Y along with the Semi are expected to be built by the new BYD Blade battery in early 2023 to hit its target of 3 million vehicles per plant. Promising this battery innovation will bring a lot of positive reception from Tesla fans. So, is the BYD Blade battery better than the 4680 cell? Documents refer to the new Model Y variant as the Type 005, and internally as the Y7CR variant. The BYD battery capacity is rated at 55 kilowatt-hours, providing a range of 273 miles. The BYD Blade battery single-cell design is compact, measuring 37.7 inches long, 3.5 inches wide, and half an inch tall. The single cells are arranged together in an array and then inserted into a battery pack. With this configuration, the use of available space is increased by over 50% compared to conventional cylindrical lithium iron phosphate batteries. Compared with ternary lithium batteries and traditional lithium iron phosphate batteries, they hold notable advantages in their enduring longevity, price, charging time, and high safety. The Blade battery can be charged and discharged more than 3,000 times. If the battery life is 400 kilometers per charge, it's equivalent to 1.2 million kilometers in the battery life cycle. In contrast, Tesla batteries can last for about 300,000 to 500,000 miles, which means 1,500 battery cycles. To make it simple and clear, Tesla batteries can last 20 years depending on the driving sessions. When it comes to comparing lithium-ion, the next generation BYD batteries have a lifespan of 60 years, which means the BYD battery life is significantly longer than the 4680. Secondly, the new variant will probably be a cheaper version, with rear-wheel drive only and a smaller battery. Since 2010, the average price of a lithium-ion EV battery pack has fallen from $1,200 per kilowatt-hour to just $132 per kilowatt-hour in 2021. For comparison, BYD Blade batteries are cheaper and contain no cobalt or nickel. An estimated 55 euros per kilowatt hour or $64 per kilowatt hour. It seems Tesla is looking to produce a less expensive Model Y at a time when inflation is rampant in Europe. In terms of fast charging performance, Tesla is a high current solution. At present, the charging current of V3 is already at the level of 600 amps, and the maximum power can reach 250 kilowatts. BYD uses a rated voltage of 570 volts with a maximum of 680 and a peak power of 120 kilowatts. Blade batteries can be charged from 10% to 80% in about half an hour. Furthermore, thanks to their 800-volt operating voltage, they can provide a range of 90 miles or 145 kilometers in just 2 minutes of charging with the next-generation BYD Blade battery innovation. Although Tesla's peak power is high, it can only be maintained for a short period of time. BYD Blade batteries love being at 100% charge or at 0%, but lithium-ion batteries prefer to stay in the 20 to 80% range. The most important information is that BYD uses LFP chemistry. The LFP has a much lower energy density than the NCM/NCA chemistry of the current cells used by Tesla and other EV manufacturers. A negative chain reaction due to high pressure and high temperature causes thermal runaway in a lithium-ion cell. Since NCM or nickel cobalt manganese cells release oxygen as a byproduct during thermal runaway, they tend to catch fire very easily. On the other hand, the Blade battery offers a higher level of safety than conventional lithium-ion batteries. LFP is more stable battery chemistry, even at temperatures as high as 500 degrees Celsius. Following an exhaustive development program, the Blade battery returned truly impressive class-leading test results where a stringent nail penetration test confirmed the Blade battery's surface temperature reached a remarkably low 30 to 60 degrees Celsius, all while emitting no smoke or fire. Further tests subjected the Blade battery to a 300 degrees Celsius furnace test and a 260% overcharging test, neither of which resulted in a fire or explosive response. The results provide evidence that the Blade battery dramatically outperforms traditional ternary lithium batteries and lithium iron phosphate technologies. This compact design, coupled with class-leading safety credentials, offers a marked competitive edge for BYD and, moreover, a step change for the entire EV industry. How do you feel about Tesla using BYD batteries? Let me know your thoughts in the comments section down below.
So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster.
Elon Musk added, "I believe that one day in the future we will develop a super fast charging electric vehicle battery, opening a new era for the electric vehicle battery industry." In the past, the Tesla CEO has always been looking for a way to have a battery for Tesla electric cars that can charge very quickly, hoping to one day have a charging time that's even faster than fueling up at the gas pump. That is about to become a reality, as recently scientists have developed a type of battery that can charge in just 1 minute. So what battery is it? And will it replace the 4680 batteries? A research team at the Korea Advanced Institute of Science and Technology, or KAIST, has developed a high-energy density, ultra-fast, rechargeable hybrid lithium-ion battery that can be used in smart electronic devices and EVs. Also, according to the scientists on the research team, the new hybrid lithium-ion battery cells are claimed to deliver far more power density than current lithium-ion batteries, without the cooling and heating problems that normally would be apparent. Accordingly, it can be rapidly charged with a high power density of 22,600 watts per kilogram, which is expected to overcome the limitations of the current energy storage system, which will truly be a breakthrough. So, a battery pack weighing 1,000 pounds could achieve a battery charging rate of 22 megawatts. That would charge a vehicle 220 times faster than current charge sessions if there's a way to deliver that much power to the vehicle somehow. So yes, you'd definitely be done with electric vehicle charging in under a minute. The research team synthesized a porous carbon hollow structure with a large surface area by changing the orientation of the polymer resin from linear to twisted. When the twisted resin was carbonized, more micropores were formed, and a carbon structure with a surface area 12 times larger than that of the conventional linear resin was created. The carbon structure created through this process was used as a capacitor-type cathode material. In addition, the anode was made using a germanium-embedded hollow carbon nanosphere material to reduce degradation and maximize the dispersion of lithium ions. The researchers found that the hybrid lithium-ion batteries using those special electrodes had an energy density which is higher than that of conventional lithium-ion batteries, and the power density characteristics of a capacitor, allowing for recharge within a minute. They also claimed that so far there are no temperature problems. 25% of a lithium-ion battery pack in a vehicle is to do with cooling them. There is a very high chance that we won't need that cooling or heating at all. One advantage that makes this new hybrid lithium-ion battery more competitive than conventional lithium-ion batteries is the cost of production. According to some sources, the price of each hybrid lithium-ion battery charging in 1 minute is only around $5.21. Meanwhile, the price of a Tesla 4680 battery is at about $11. So the cost of each hybrid lithium battery is much cheaper than that of the 4680. Researchers at the Massachusetts Institute of Technology said that research and development, particularly in chemistry and materials science, has been the major factor in dropping the price of the hybrid lithium-ion battery. The group examined data from a wide variety of sources, reaching the conclusion that improvements to the technology through research and development have been responsible for at least 50% of the price reductions achieved so far. Dr. Micah S. Ziegler at the Institute for Data Systems and Society at MIT, a member of the researcher team, also analyzes that efforts to increase cell charge densities made a 38% contribution to the overall cost reductions of battery, while work to reduce the cost of cathode materials made up 18%, and reductions in non-materials costs constituted 14%. Not only that, the lifespan of the hybrid lithium-ion battery charging in 1 minute can be up to around 80 years, which is similar to 1.2 million miles capable. Meanwhile, the life of 4680 Tesla battery cells is designed to be used for 20 to 30 years. Thus, the lifespan of this ultra-fast charging battery is about 2.7 times as high as the lifespan of the Tesla 4680 battery. So, when will this ultra-fast charging hybrid lithium-ion battery officially be put into mass production? Currently, the scientists over at KAIST say that they are only in the early stages of research and development of this battery, hence it will still take a few more years to officially bring it to the market. On top of that, has any manufacturer produced a 1-minute rechargeable battery yet? Previously, an electric vehicle startup, Fisker, announced a battery that charges very quickly in just 1 minute. But after that, Fisker said that it had given up on solid-state batteries after having announced a breakthrough that was supposed to enable 500 miles of range and 1-minute charging in its electric cars. Fisker believes that the technology is nowhere near ready for commercialization. In the meantime, other battery manufacturers with scientists have also moved one step closer to producing super-fast batteries. Accordingly, researchers from the University of Queensland and the Australian Graphene Manufacturing Group, or GMG, have presented a new graphene aluminum-ion battery that is supposed to charge 60 times faster than current lithium-ion batteries in only 10 seconds, and is a more sustainable battery prototype with a lifespan 3 times the length of current lithium-ion batteries, with an estimated lifetime of 3,000 charge/discharge cycles. Meanwhile, a typical lithium-ion battery lasts about 1,000 cycles. Additionally, StoreDot, the pioneer of extreme fast charging, or XFC, battery technology for electric vehicles, has revealed its strategic technology roadmap, labeled 100NX, which will deliver batteries capable of charging 100 miles of range on just a 2-minute charge, with mass production readiness planned within 10 years. StoreDot is also firmly on track for its first milestone for global automotive manufacturers, which include producing its silicon-dominant anode XFC lithium-ion cells at scale by 2024 that will be capable of delivering 100 miles of range in 5 minutes of charge. And most recently, the Israeli startup has successfully demonstrated its 105 extreme fast charging battery technology, publicly charging a full-scale EV battery pouch cell with enough energy in 5 minutes for 100 miles of range. The demonstration featured a 300 by 100 millimeter pouch cell produced at EVE Energy's manufacturing plant in China. The battery was charged under a 10-minute time limit, during which the cell charged to 20 ampere hours, or amp hours, exceeding the 0% to 80% capacity target set for the demonstration. Furthermore, an extreme fast charging battery tech developed by the Israeli startup got one step closer to commercial viability with an investment from Volvo Cars Tech Fund, the Swedish carmaker's venture capital arm.
Maybe. Lithium-ion covers a very broad range of technologies. You can have an enormous difference in the power density and the energy density.
In recent years, lithium-ion batteries have taken the world by storm, controlling more than 90% of the global grid market, from your laptop to electric vehicles. You're probably watching this video on a device powered by a lithium-ion battery. However, current lithium-ion batteries have great limitations which affect performance, and can even take you all night to charge if your electric car runs out of battery. Instead of finding new solutions, researchers in Texas are making great efforts to enable lithium batteries to charge 5 times faster. So what exactly is this technology, and how will it improve range and charging time?
Right now, they need so much energy, you'd have to charge them too often.
Lithium-ion will still be dominant for a long time, even if you have other technologies. However, lithium-ion batteries still have their limitations, and these hold back many of the advances we could have made as a human race. They're not as robust as some other rechargeable technologies. Lithium-ion batteries require protection from being overcharged and discharged too far. In addition to this, they need to have the current maintained within safe limits. Every time a battery charges, lithium ions travel back and forth between a positive electrode and a negative electrode, particles in electrodes, causing them to crack and degrade over time. Electrode damage reduces a battery's charging capacity, which in turn reduces the range. However, it'll take a long time for new batteries to hit the market, and moreover, perhaps we'll never eliminate lithium-ion completely. So why don't we just improve on something that's already been proven to be reliable?
A better battery changes everything. That's what you need to know about the future of lithium-ion batteries.
To ensure that there are no barriers facing EV uptake, researchers at the University of Texas at Austin are addressing the two biggest challenges currently facing EVs: limited range and slow recharging, by creating a new type of lithium-ion battery electrode. The study was published in the Proceedings of the National Academy of Sciences. They fabricated a new electrode that has the potential to unleash greater power and faster charging without sacrificing life. The electrode, the positively and negatively charged part of the battery, was made thicker using magnets to create a unique alignment that sidesteps common problems associated with sizing up this vital component. Scientists say the price of new lithium-ion batteries will drop by 65% due to fewer complicated steps. For comparison, the average price of a lithium-ion EV battery pack is $101 per kilowatt hour in 2022. Thus, it would only cost about $35.35 per kilowatt hour to own a lithium-ion battery pack with new electrodes. This is good news for electric vehicle manufacturers and consumers. So how did they implement this technology?
Lithium-ion battery, because the lithium ions move from side to side.
To create thickness, the team used thin, two-dimensional materials as the building blocks of the electrode, and then used a magnetic field to manipulate the orientation of the materials. During the fabrication process, the researchers used commercially available magnets to arrange the two-dimensional magnets in a vertical alignment. This created a fast lane for ions to travel through the electrode. The magnetic field used by the researchers could facilitate twice the range on a single charge for an EV, compared with a battery using a current commercial electrode. For example, the maximum driving range for a Model Y is 330 miles on a full charge for the base long-range trim, and 303 miles for the performance trim. With new electrodes, the Model Y's range can be significantly increased up to 660 miles. This is indeed an amazing increase in range. Guihua Yu, a professor in UT Austin's Walker Department of Mechanical Engineering and Texas Materials Institute, stated, "Two-dimensional materials are commonly believed as a promising candidate for high-rate energy storage applications because they only need to be several nanometers thick for rapid charge transport. However, for thick electrode design-based next-generation high-energy batteries, the restacking of nanosheets as building blocks can cause significant bottlenecks in charge transport, leading to difficulty in achieving both high energy and fast charging. Thicker electrodes force the ions to travel longer distances to move through the battery, leading to a slower charge time. The typical horizontal alignment of the layers of the material that comprise the electrode forces the ions to move back and forth. The magnetic field used by the team aims to solve this issue." Zhengyu Zhu, a graduate student in Yu's research group who is leading this project, said, "Our electrode shows superior electrochemical performance, partially due to the high mechanical strength, high electrical conductivity, and facilitated lithium-ion transport thanks to the unique architecture we designed." The team also compared their electrode with a horizontally arranged electrode for experimental control purposes. The vertical thick electrode was recharged to 50% energy level in 30 minutes, whereas the horizontal electrode was recharged to 50% in 2 hours and 30 minutes. This means 5 times faster charging time than Tesla's 4680 batteries. We all know that with a standard 120-volt outlet at home, it'll take around 15 hours to get your Model Y fully charged. So, with the new electrode lithium-ion battery, you only need 3 hours to charge. If you've got access to a Tesla supercharger, it will just take 3 minutes to charge up a Model Y. So, with such a fast charging speed, will it affect the battery life? Texas researchers said that increasing the energy density of the cells while maintaining other factors such as safety and lifetime constant at a high level, about 25 years. They are still continuing to find a way for lithium batteries to have a lifespan of 50 years. The researchers also emphasized that they looked at just a single type of battery electrode in this research. Although they're still experimenting in the laboratory, they expect lithium batteries with new electrodes to be available in April of 2023. If successful, it could significantly reduce the cost of lithium, removing one of the most significant bottlenecks to battery production ramp-up. How do you feel about this technology? Do you believe it will be released in the coming years? Let me know your thoughts in the comment section down below. Otherwise, that's it for today's episode. Thank you so much for watching and for all of your support of our channel. As always, if you enjoyed our video, please leave us a like, share the video, subscribe to the channel, and ring that bell to stay up to date on exciting developments in the world of EVs and green technology. Once again, we thank you so much, and we hope to see you again next time. Until then, take care and be safe.